Hey all, welcome back to my channel. In this video, we're going to see what is ether frame, what is switch framing, what is switch flooding, and what is MAC address table. So let's just understand what is ether frame. As we all know, frame is a PDU at layer 2 of OSI model, and layer 2 is our data link layer. So on the device which work at data link layer are switch. So switch we call as layer 2 device because it worked on MAC addresses. So whenever a switch gets a data, it gets the data in terms of frame, and that frame is what we are going to understand here. What is ether frame? And it works on Ethernet. So Ethernet wiring, right? So yeah, let us understand what is ether frame. Ether frame is minimum of 64 bytes of data in a frame, and maximum it can go up to 1518 byte. So first 7 bytes of preamble of this frame is a preamble, and preamble is a part of ether frame which define to synchronize the clock between the devices. So next we have 1 bytes of SFD, start frame delimiter. It is a 1 byte which says from here my main frame starts, and from after that we have destination MAC address, source MAC address, and type length. Destination MAC address is the end device MAC address for which this frame is destined to, and source MAC address is the device MAC address which exists on the NIC of the sender device. And the type length consists of the upper next layer information. For Ether, it is network layer information like it is IPv4 or IPv6, etc. So this type like says in this data payload, the upper data is going to be IPv4 or IPv6. And after that we have data payload section which consists of 46 to 1500 bytes, which is the actual data, consists of upper layer header also. And then we have CRC, cyclic redundancy check, and frame check sequences. It check whether the frame which it received is not corrupted, it's fine. So that's what it check here. So a switch transfers the data in terms of frames, and this is what ether frame is. So what is frame switching? Switching. So yeah, let's just understand we have a switch here. Let's just understand this is a switch, and we have devices connected to the switch. Whenever a PC wants to send data to switch will have to take decision like how it is going to forward this frame. So this process, whenever a switch receive a ether frame from sender device, it do a frame check sequence to determine how it should forward the data. This process is called frame switching. So let's understand how frame switch happen in switch. So whenever a switch receives these frame, it run frame check sequence on types of switches. Like how what are the type of switch which we are using. So in Cisco three layer hierarchy, we have three layer, right? First one is core layer, distribution layer, and access layer. We will be understanding this with terms of with the terms of this level with this Cisco layer 3 hierarchical model of LAN designing switches devices. So first type of switches which we are having is store and forward switches. This is a multi-layer switch uh, definition by Cisco, where it says whenever this type of switch receive a frame, it do frame check sequence on whole frame. Like for example, if this switch is receiving 10 frame, in the whole 10 frame, it stores the frames and check for frame check sequence and check for any corruption or error. So this is a very classic and recommended switch, and this is how it forward the frame. So if this is a store and forward switch, it will do the frame check sequence on all the frames which it receives. Okay, if this switch varies from, let's say, from store and forward switch to cut through fast forward switch or cut through fragment free, it changes the algorithm with which it forward the frame. So if it is store and forward switch, it is work on core layer because I said it is classic. It's a multi-layer switch. It can be layer 3 also. Run frame check sequence on whole frame, like all the frames. And the Cisco switches series will be 4500 and 6500. If the switch is cut through fast forward switch, it work on access layer. It's a basic switch which is L2 switches, which are of series Cisco series this, and run frame check sequence only on destination MAC address. As we see earlier, we have in either frame, we have destination MAC address, right? On this frame, it do a frame check sequence and then forward the traffic. So if it found in the frame that the destination MAC address is D, it directly forward the frame to D. If if MAC address of D is in the switch table. So, what is the next type of switch? We have cut through fragment free switch. It's a compromise between these two, both the switches. First is classic, and then second one is a L2 switch. So, it is a compromise between them where they decided to run frame check sequence on first 64 bytes. So, let's understand if a sender is sending 1000 frame, it will not, the switch will not now store this frame check sequence on whole frames. It just do frame check sequence on first 64 bytes and then it forward the data. So this is also recommended, and it work on distribution layer of Cisco level hierarchy of devices. So these are the frame switching scenarios. It depends on which type of switch we are using for forwarding method. Now let's just move to frame flooding. Frame flooding is determination of on which port of frame the data should be reaching its destination. For example, if we have a switch and we know the destination is D, so frame flooding happen. It depends on the table, CAN table, or what you call is MAC table of a switch. If no entry is there, it will do flooded to all the ports. If A is sending data to switch and saying that I need this data to send to D, if switch will check its MAC table. If the data and port related to D MAC table is there, then it will do unicast, means forwarded to that port. If it does not having a D data, it will do flooding. So it depends how frame flooding is happening. Now we'll see what is MAC address table. MAC address table is a CAM table for switch, and the aging time is the expiry time for each entry will be 300 second by default. Rather explicitly, it can go up to 1 crore. And the MAC address table is made up of the following columns: VLAN, MAC addresses, type, how this MAC address has been saved to this MAC table, and the port. So let's say we have this switch, right? And here we have A device, here we have C device. It is having this MAC address, this is having this MAC address. Okay, and this is having port ID of 0 by 1, 0 by 2. So the MAC address table will be like in content 1, 2, or 1, 2, and 2 like this. And let's say the data entry will be VLAN, let's say 1. MAC address is BBBCD, dynamic, port is 0 by 1, port is 0 by 2, dynamic, and AAA. So if this is the network topology, then the MAC table will look like this. So MAC table is made up of following column: VLAN, MAC addresses, types, port, and dynamic entries will persist through a reboot. It's it's incorrect. It's a static. If the Yeah, we can give MAC address to the devices statically as well as dynamically. If it is static, it will persist in a switch through a reboot. If it is dynamic entries, it will not exist even on a reboot. so it has a aging time. So that's what the MAC address table is. And for any doubts and stuff, please reach out to me in the comment section. I hope that you like this video. Thank you.